Now the range of different switches that I've got linked up are, I've got the clock, which would be the CPU clock. I've got a line for resetting the program counter. I'm not completely sure that I'm going to need that in the finished thing, but I put it in anyway. A thing for increasing the program counter, and then there's storing and getting data back out of the program counter, and then key 12 is just publishing the keyboard. So why do we need two switches to store into the program counter? Well, it's a 16-bit program counter, and we can only store an 8-bit number at any given time because we've got an 8-bit data bus. So we store 8 bits of the 16-bit number into the high part of the program counter, and then we switch to the low part of the program counter and store 8 bits in there. So we can store an 8-bit value into the top 8 bits of the program counter, store an 8-bit value into the lower 8 bits, so now we've got a 16-bit number. We can increase the program counter a few times, and then we can get those 8 bits back out of the top 8 bits or the bottom 8 bits. We can get them back onto the data bus and read them. So when would you need to do that? Well, if you want to jump to a certain location in memory, you would set the value in the program counter. If you want to call a subroutine, you'd get the current value out of the program counter, jump to your subroutine, and when you want to return, you'd put the original value back into the program counter. So that's going to be storing it on the stack as a subroutine. Right, simplest of the lot, we want to be able to increase the program counter. So that's button 3, and also we need to do the clock, because how this thing works is it's synchronous to the clock. So if we hold down 3 and do a clock cycle, we see that the program counter is increased to 1. Do another one, and it increases to 2. Then it increases to 3, and it's going to keep counting up like that. Is that clear? Yeah, I think that's pretty clear. So if we do the clock cycle without holding down the increase button, nothing happens. If we just press the increase button, nothing happens. You've got to hold the increase thing in a low state. Is that a low state or a high state? That's a high state, actually, sorry. So we bung it into a high state, and we do a clock pulse, and then we increase the program counter. Now, obviously, we're only increasing the bottom 8 bits at the moment, but if I sit here tediously pressing this for ages and go all the way up to 256, let's use the other hand for that. Okay, so we're getting up towards 255 now. That's about it. Okay, 254, 255. When we increase by one more, we've increased the high byte of the program counter, and we carry on increasing the low byte. So I've got a value of about 250, whatever that is, 260 or something in the program counter there. And so that seems to work. Let's do the reset. So to do a reset, you hold down 2 and do a press on the clock. It's a synchronous reset as well, and it's gone to 0. Right, so what happens if we want to put a value into the program counter then? Well, if we put a value on the keyboard here, so let's put 10 on there. Let's check, publish that. Yeah, this project has taught me that connectors are one of the most difficult things in the whole of doing projects, because 9 times out of 10 when I get a problem with this project, it's been that the connectors have been useless. So here we go. Right, so we can now publish my value of 10, and there's 10 on the data bus. Let's just check that. Let's put 255 on there just to check all my lines are going. 255, brilliant. So if we publish whatever that is, what's that? 240. Okay, so how we store something in the program counter is we have to publish onto the data bus with 12, and we can store with 5. So we publish with 12, we store with 5, but it's a synchronous store, so we also need a click on the clock. There you go. Now the reason that I've done that is I don't want the program counter increasing at random intervals. I want to increase it exactly on a clock pulse. So in order to store for the program counter, you have to have a clock pulse going as well. So I've stored 240 in the high section there, and let's put 129, publish. Store for low is 6, so we hold down store and we do a clock pulse. So there you go, I've stored 240 in there, 129 in there. And if I want to get them back, so let's turn that clock off so we can see that we're not getting the value from turn the keyboard off so you can see we're not getting the value from the keyboard. let's publish. Let's see, so what's published there? So publish is 7 and 8. So if we publish with 7, we publish the value of 240 onto the data bus, and publish 8, we should get a value of 129, exactly. So we can put a value into the program counter, we can get a value back out, and we can also increase the value. There it goes. So let's try and just do a very simple little bit of addition in the program counter and see if we get the right result. Okay, so my target then is to put a value of 1,000 into the program counter, increase it by 30, get the value back from the program counter and see if it's 1,030. That should work, shouldn't it? So how it was 1,000 in binary? Well, what we need to do is split it into two lots of 8 bits. So 1,000 divided by 256 is 3, remainder 232. So we want to put a 3 in here and a 232 in there. So let's get a 3 first. That's a nice easy number, isn't it? 3. So we publish 3. We store it in the high section, which is the high section of the program counter, 5, which is like that. So we've got a 3 in here. And we want 232. So find out what 232 is in. Oh, got a loose connection somewhere. There we go. There's something wrong with this. This thing's got a loose connection now, I think, in here. 200. Oh, look, that's 232. So we'll store 232. So we want to store that with the 6 key. So press 6 and store that in there. So I reckon we've now got 1,000 in the program counter. So to increase the program counter, we hold down 3, which is increase, and do clock pulses. So we'll do 30 clock pulses. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 20. 1, 2, we're going to see it overflow up into there. 3, 4, 5, 6, 7, 8, 9, 30. Okay, so now I reckon this is 1,030. So if we publish the high section with, that's an 8 to publish that. Sorry, publish is 7. Right, so we've got 4 in there. We've got 4 in there, and we've got 6 in there. So 4 times 256 is 1,024, plus 6 is 1,030. Exactly, so we've got 1,030 in the program counter. So I've managed to store a 16-bit number in the program counter. I've managed to increase it. I've managed to publish it, back it out again, and check that it works. And that is pretty much all the program counter does. So in this particular, the way I've implemented it then, out of this 20-way IDC connector, the 16-bit value of the program counter is going to go out and go to the memory board so that it can point to locations in memory and allow you obviously to read values from memory, read the next byte from memory that the program counter is pointing to so the program can run.